Hi everyone, we are Diana, Theo, and Aparna, students from Professor Blemker's Biomechanics class at UVA. One day we were talking after a class on sports biomechanics about basketball, and a question came up. Do basketball players really have to be tall to be good at it? Is there a way that we can debunk this possible myth? We decided to give it a shot, haha, get it? And do a little thought experiment. Biomechanics is the study of mechanical aspects of the human body. It helps us to examine how different body parts and compositions move. For example, agility, as seen here, is the ability to move swiftly and easily, like a cheetah which can navigate its movements with control.
To better understand agility, it is important to define angular velocity and angular acceleration. Angular velocity is described as how fast a particle is rotating about a particular point, also known as the rate of change of angular displacement over time. Angular acceleration is the rate of change of angular velocity. Angular acceleration is important to understand torque. Torque is defined as the measure of force that can be applied on an object and make it rotate about an axis, which causes it to acquire angular acceleration. Torque can also be defined by the equation T equals I times alpha, where T is torque, I is the moment of inertia, and alpha is the angular acceleration. Angular acceleration is extremely useful in the game of basketball because it can allow an attacker to spin around a defender and get to the basket or pass to another teammate. The higher the angular acceleration, the faster the spin, and the faster the player can get around to the defender. It is also important to understand moment of inertia. Moment of inertia expresses the body's tendency to resist angular acceleration, which can be defined by a number of equations depending on the shape of the object and the axis of rotation. The main thing that affects moment of inertia are the mass of the object and the length from the axis of rotation. For example, figure skaters draw their hands into their body to decrease their moment of inertia, making their bodies resist angular acceleration less and therefore be able to spin faster.
Alright, let's do an example of how the size of a player affects how agile he is. Take for example Anthony Davis, 6'10", wingspan of 7'6", and 254 pounds. Now compare him to a player like Steph Curry, 6'3", wingspan of 6'4", and 190 pounds. Much smaller than Davis, but they're both in the NBA. We will represent Davis as player 1 and Curry as player 2. If their arms are stretched out like the following drawing, we can model their bodies as cylinders with an axis of rotation down its center. Keep in mind this is a theoretical modeling of the players. The moment of inertia can then be calculated with the equation I equals 1/2 mr squared. Now, in order to calculate the angular acceleration of each player, we will use the torque equation. Let's just say that both players can produce a torque of 50 Newton meters. We will use the length of one arm to be the radius in meters and convert their weight into kilograms, as shown in the following drawing. Plugging all those values into the equation, T equals IA, we get that the player 1 has an angular acceleration of 0.6 meters per second squared, while player 2 is 1.4 meters per second squared. A huge difference in angular acceleration. Player 2, who is the shorter player, can spin around faster than the taller player, given that they both produce the same amount of torque. A taller player, who would have longer limbs and weigh more than a shorter player, will have to generate a higher torque in order to gain the same angular acceleration. This means that a shorter player is more agile than a taller player while having to put less effort in producing enough torque to spin.
Now, can you guess which position on the court has to have the most agility? Yep, it's the point guard. Now, if that math wasn't enough proof for you, here's a TikTok video we found that might just do the trick. This little girl overtook a professional football player. Why? Because she's closer to the ground and can generate a higher angular acceleration. She's more agile. So guys, here's proof that you don't have to be tall to be a great basketball player. We hope you enjoyed our video. Stay safe and have a wonderful day.